The purpose of today's lesson is to talk about proportional relationships. Proportional relationships. And proportional relationships are how ratios and proportions can help relate and represent mathematical quantities from a given situation. We're going to do some examples, so it just explains it with examples instead of doing a definition. Alright, let's take a look at this first one. Julie is picking teammates for her flag football team. She picks 3 girls for every boy. 3 girls for every boy. We're going to complete a table and see how this relates. So if she has 1 boy, because 1 boy, and there's going to be 3 girls, then this would be represented by 1 to 3. If she has 2 boys, then she's going to have 6 girls. What happens if she has 9 girls? Well, now we're going backwards and we're trying to figure out the boys, and it's 3. But notice the relationship here. Each one is getting, the number of boys is being multiplied by 3. So there's the relationship. It's a proportional relationship. 4 times 3 is 12. And then we're going to graph the relationship girl to boy on this graph here. And of course the boys is going to be represented down here because that's in the X column. The girls is going to be over here. And we're just going to plot these points. Okay, 1 boy, we'll just do a couple of these. We'll go here, 2, 4, 6. 1 boy is going to be 3 girls, 1, 2, 3. Put a point there. 2 boys is 6. 3 boys is 9. And 4 boys is 12. Look what's happening. Really, I could have just gone, I kind of did this. I went over 1, and then I went up 3. And then I went over 1, and I went up 3. That is a proportional relationship. Over 1 and up 3. Another way to think of it is you could go up 3 over 1, up 3 over 1, up 3 over 1. That's another way to think of it. Find the ratio of girls to boys for several different ordered pairs in the table. Okay, so if you look at the girls, we've got, I'll use these two because I can see them. I've got 12 girls and I have 4 boys, which is the same as 9 girls and 3 boys, which was the same as 6 girls and 2 boys. So those are all the relationships. Those are proportional relationships. Fill in the boxes to show the relationship between girls and boys on Julie's team. Well, which one did we multiply the 3 by? What did we multiply the 3 by? Look back at the graph, at the table I mean. We did 3 times the number of boys. And over here is the number of girls. Because in order to get the boys to be equal to the girls, you would multiply by 3. Use the equation and graph to determine how many girls would be on the team if Julie chose 10 boys to be on the team. Okay, well, I'm going to let this be y equals, and 3 times the boys, that's going to be our x. Notice we have 2 variables now. We've got 2 variables involved. So I have 10 boys. And who represents the boys? This is x and this is y. So if I were to use that equation, if I know x is 10, I would do 3 times 10. And so how many girls would there be? Y equals 30. So there would be 30 girls. Use the equation and graph to determine how many boys are on the team if Julie chose 18 girls. So once again, I'm going to use y equals 3x, but I know y is the girls and x is the boys. So now I'm given girls. So y is 18. So this is where we're substituting, and then we will solve for the number of boys, which is 6. So 6 boys on the team. Okay, now we're going to talk about the constant of proportionality or proportional constant. Remember in that previous example where we talked about the ratio that related the number of boys to girls was 3? Well, this is our proportional constant. Proportional constant. That's what they're talking about up here. And in that example, it was 3. So it was like the multiplier to go from x to y. What did we multiply by? We multiplied by 3. So that was our proportional constant. Okay? We're going to find our proportional constant in this next problem. Carmen is making homemade root beer for an upcoming charity fundraiser. The number of pounds of dry ice to the ounces of root beer extract flavoring, that's what they put in there, is proportionally related. If Carmen uses 12 pounds of dry ice, she will need to use 8 ounces of root beer extract. Okay? Write a ratio or proportional constant, these are the same thing, synonyms, that relates the number of pounds of dry ice to the number of ounces of root beer extract. Okay, so the ratio is pounds of dry ice over the ounces, OZS, that's ounces, of root beer. I'm just going to put root beer, okay? It helps me immensely to write this out in words. So then let's go back up here and it says 12 pounds of dry ice. So I'll find the number and I'll look for the label. Well, it's 12, so that's dry ice. That would go in the numerator. And then we have 8 ounces of root beer, so that goes in the denominator. We could divide each one of these by 4, and that would give us 3 halves, also known as 1.5. You can use either of these if you like fractions or decimals. Write a ratio proportional constant that relates ounces of root beer extract to the pounds of dry ice. Now we're going the other way. We're going root beer to dry ice. Okay? Well, root beer was 8, dry ice was 12, so that's 2/3. So sometimes you get to choose. It depends on what they're asking. And it's specifically, you have to go with what they specifically ask for. Okay? Let's complete this table to show the relationship between number of ounces of root beer extract X and number of pounds of dry ice. Okay, so we have 0 ounces of root beer. Well, then we're going to have 0 ounces of dry ice. Okay, if you can see, there's going to be a pattern going here. I think you kind of see that these two, we're going to add 1. So what do you think would go in here? Well, 1 would go in here. And then if you have 1 ounce of root beer, you're going to have 3/2 pounds of dry ice. How did you get there? Well, you multiplied this by 3/2. So that is our ratio. That is our proportional constant. That's what we're going to be using each time. So if you want to, you could just go through here and fill this in. You're multiplying this number by 3/2 every time. And then you're going to fill this in. Well, 3/2 times 2, that would give us 3. That's 9/2, which you can also write as 4.5. Whatever works for you, if you prefer decimals. 1, 2, 3. It looks like this is going to be a 4. Oh, here's a big jump though. This is plus 4. So obviously it's not going to just continue with the pattern of adding 1.5 here. We're going to have to take 8 times 3/2, which would be 24 halves, or 12. Okay, and then we get to graph it. Well, this is root beer, because remember, this is always your X here, and this is your Y here. And that's how we relate it from the table. Root beer, and this is ounces. You want to label. And this is dry ice. and that is in pounds. Okay, I'm going to let you finish that graph, and I'll do it, and then you see if you got it right. Okay, does yours graph look like mine? Alright, now we're going to go ahead and connect these. Try to get a nice straight line here. Good. Alright. And here's the deal. We get to connect these points because you could maybe have 1.5 ounces of root beer, and then you would need to know how many pounds of dry ice. But on that previous problem, could we connect those points? Could we have 1.5 girls or 2 2/3 boys? No, it would just be the points that we graphed. So this is what your graph looks like. Okay? What is the proportional constant for this relationship? Well, we decided that that was 3/2. That is our ratio, or our proportional constant, because it was 3 to 2. That's what we multiplied by. I like to use that multiplier from x to y. That's your proportional constant. All right? Write an equation that shows the relationship. From dry ice, that's our y. So what did we do? We took our x and we multiplied by 3/2. All right, we're going to take this a step further now. We're going to relate the proportional constant to the unit rate. And you recall from 6th and 7th grade that the unit rate is when you talk about one item to one of the other. All right, so this is the unit rate of y with respect to x is the amount of y that corresponds to 1 unit of x. There's where it's important. Your x can only have 1 unit. So in the previous problem, Carmen was making homemade root beer. Expressed the proportional constant as a unit rate. Well, remember when the proportional constant was 3/2? Remember how we had that problem? But we want this to be a unit rate, so we would say it would be 3/2 to 1. Or you could say 1.5 pounds of dry ice to 1 unit of, or 1 ounce of root beer extract. That has to be the unit rate, because you always have to have 1 in the denominator. What would the unit rate be if we interchanged the roles of x and y? Well, if we interchanged them, which we did, then we did root beer to dry ice, and it was 2/3. What the unit rate would be 2/3 to 1. So you would need 2/3 of an ounce of root beer extract for every 1 pound of dry ice. All right. In the problem below, use the properties of a proportional relationship to help you understand the question. I'm going to pause this, and I want you to read this on your own. All right. Did you get a good understanding? Do you have some highlights in there of it? Well, then you know that he's talking about 75 square feet of concrete for every 3 hours. That's our proportional constant. And now we're going to fill in this table. So 75 to 3. Well, here it is. 3 hours, 75 square feet. So we have to fill in the rest of this. Go ahead and do that. I'm going to give you a hint. How do you go from 3 to 75? What's the multiplier? The multiplier is 25. Use that hint.